number 3. I'm going to go through each of these. I hope that that will help you. Some of you, again, this is about being neat and organized, and I don't know, I have this need to be spatial. So the first problem was b minus 3, and the other one has a denominator of 2b plus 6. All I had to do was find the least common denominator. And in factoring them, I could see that they both have, well, this one is b minus 3, and this has b plus 3. What do they have in common?
B and 3. Oh, B.
Nothing? Nothing. This is some number minus 3, and this is that same number plus 3. So they have nothing in common. Okay? So in order to make them common, I have to put this here. So it's going to be 2b, 2 times b plus 3. And what do I have to put on this side? B minus 3. So the factors for this would be 2.
Wait, why do you have b minus 3?
I factored them. This, and it's kind of like, oh, I have a marker. If this is 4, and this is 3, and I want them to have a common denominator, what am I going to multiply that 3 by? The 4. And what am I going to multiply this by? The 3. So that's all we're doing here. This one was b minus 3. This one isn't b minus 3. So I have to multiply this side by the other one. And then I would have to multiply this side by what? Yeah, this one. So this would have to have, so if it's b minus 3, I'd have to also add 2b plus 3. Are they now identical?
Yes.
2, b minus 3, b plus 3, 2, b minus 3, b plus 3. That's what you're doing when you're doing all of these. You're comparing them, and they have to have the same denominator. What?
You're like actually trying to solve it and not just get the
Well, this particular problem, they just asked you to find the common denominator.
If you were trying to actually solve it, would you times the top number by?
Absolutely, yes. Yes. Why do I have to multiply this side by, well, here, if I had 1/3, why do I have to multiply the numerator by 4? Because remember, that's the power of 1. The power of 1 allows you to change your numbers. And that concept will follow you through calculus. I mean, it's one of the most, that's why it's referred to, the power of 1. You're going to use that idea of 1 and how you can change numbers to suit your purposes. And that's all this is. That's the big picture. How can I figure this out? What do I know, and what do I know about the power of 1? Well, I'm going to use the power of 1 right here. Okay, that's it in a nutshell. Simple? Everybody say yes, Miss Lyle.
Yes.
I know you're not thinking it, but it really is. I might even dance for you one day, you never know. Or sing, and you don't want me to sing. Okay, let's go to the next one. So the next one, again, I always start, I have what the problem is, and then what do I need to do? I factor it. Well, they both have A's. This one is missing something. What does this side need? A plus 1. And so I know that it has to be a plus 1 over a plus 1. These problems weren't asking you to do that. They were just asking you to find what the least common denominator. So the least common denominator is a times a plus 1. Okay? So far, so good.
We were just
Yes, no?
Yes.
Okay, deep breath.
So if it already has last part of the annex, you only multiply by the other part?
Yeah.
Which I
What
Then
was
we just
messing
leave
me
it
up was
back.
that I thought you actually had to do the multiplications. Like once I got there, I was trying to make it a squared plus a, as opposed to keeping them separate.
Yeah, that's
We're
right.
keeping it simple, okay? So number 5, what kind of a problem is that x squared minus 9? Difference of perfect squares, okay? And does this also have a name?
A square.
Trinomial, perfect square trinomial.
Bingo, nice job. A perfect square trinomial. Because what are the factors of 9 that are going to give you 6? 3. So what are the two factors going to be? X plus 3, x plus 3. Yeah, these are very nice. It's nice to know those. Okay, so I can factor. I know that the difference of perfect squares, this is a plus 3, this is a minus 3. And this has 2 plus 3's in it. So what, does this side have 2 plus 3's? No. So what am I going to have to add onto that side? X plus 3. And what am I going to have to add onto this side? X minus 3. Okay? You feeling better? Okay. So that was 1 through 5 and 6, right? 6.
So the final answer.
Well, let me see. So that was it.
Should you leave it like
So,
that or should you say?
That's all we're using right now.
Wait,
Just
you write it as x plus 3 squared times x minus 3?
no, and I'm going to tell you why. And we're going to get there in a few minutes. Right now, all we're doing is looking for factors. Today's lesson, I hope we can get to, it will be important for you to see what you have in your denominator. Okay? It's all about understanding how things behave. It's like understanding old people, all right? Old teachers, they like it certain ways. Okay, so, all right, how about this one? Can I factor z squared? Is the first one a perfect square trinomial?
Yes.
No. Wrong.
Wrong. A perfect square trinomial is the two binomials are the same. Okay? Is this a perfect square trinomial? No. Okay, but do we know what the factors are?
Yes.
Okay, so let's look at what we have for factors. Whoops. Okay, so would you agree that it would be z minus 5, z minus 3, and z minus 3, and z plus 1? Okay, so they both have z minus 3. That one has a z minus 5, this one doesn't. So what do I need to add to this side? Z minus 5. And what do I need to add onto the other side? Z plus 1. Okay? Alright, so now that we got that groove going, let's use it. Okay, so that was number 6, correct? Okay, number 7 was asking you to simplify. Guys are funny sometimes. If I said to you I had 3/4 plus 1/10, what is the common denominator or the least common denominator?
20.
20. Okay, I've seen 40. I think I've seen a 60 floating around. Why wouldn't you go with the least common denominator so you know that you want, and you're going to deal with this just like you would something else. So what am I going to multiply both sides by to have the same numerical coefficient?
2.
What am I multiplying by 2?
Multiply
10.
10 by 2.
I'm going to multiply this by 2. All right, so if I multiply this by 2, what do I have to multiply this by?
5M.
This one has to be 5.
Isn't it be 5M?
Hold on, dealing with one step at a time, okay? And then this one has 1m, and that one is m squared, which means it's what? M and m. Okay. I need a different marker. Running out of markers here. So what has to be multiplied on the left? M. So I need to multiply, add another m here. So I have 5m times 3 over what? 20 M squared plus, would you go next door and ask Strasser for another marker, please? He has an extra one, because these three out. And then what am I going to have here? 2 over 20m squared? And then can I combine like terms? $20m squared. So what do I have here? 15m plus 2 over 20m squared. Can I add 15m plus 2?
No.
Nope. No? So that's my final answer.
That's what I got you.